5:03 in the evening, 45 minutes after sunset here in John Day, Oregon, almost at 45 degrees north, slightly less than 45 degrees north latitude. What you're seeing right here is the core of Messier 31 at a 0.2 second exposure. So we're 45 minutes after sunset, and if you ever do a Messier marathon in March sometime or early April, this 45 minutes after sunset is when you would begin your marathon, and you'd probably start right here with Messier 31, 32, and they'd be very low on the horizon, and Messier 110, which is located somewhere down here. This is like a full aperture view at 0.2 seconds. It's roughly a 6-inch view through a 6-inch scope at the eyepiece at roughly 30x. And I'm going to pause now because we are about to take up in another half an hour to 45 minutes the NGC 700 to 749 El Cuatro Tour. There are high thin clouds in the air, but I have noticed recently that most of these clouds have been coming off the mountains to the Cascades to the west and then begin to dissipate as it gets a bit cooler, surprisingly so. But we'll go ahead and give it a shot anyway, and we've just done this experiment. So, hang in there, and I'll hang in there. I'm wearing extra thick clothing tonight, so hopefully I will not be chitter-chattering during the second tour that should occur almost immediately after the first, and that will be the NGC 750 to 799 tour. So we can hopefully get through this tour to NGC 1000 or by the winter solstice on, I believe it's the 21st this year, but hopefully it could be the 22nd because I certainly need the extra time. Okay, we're now an hour in after sunset, and this is our view of Messier 31, 32, and we're getting hints of Messier 110 here. And once again, we're using 6-inch scope equivalent settings. Let's go ahead and take another break and wait for another 30 minutes or so before what I would assume to be sky dark. Remember, there are high thin clouds, very visible up there, and this is probably not the best night for running this test, but notice we're starting to get some hints of the dark lanes to the north and the west of the core. Well, I'm suspecting this may be my only outing tonight. It's now 5:25, so we're about an hour and 7 minutes into the post-sunset cycle that I've been exploring. So we're going to start with this 0.2 second exposure and then push it from there and get a sense of, under poorish seeing with high thin clouds drifting overhead, what we might actually be able to get to see. This will be a separate astrovid from if I do get blessed by the night sky and am able to do the NGC series 700 to 749. By the way, I counted some 41 studies, and that's typical. Roughly 80% of the NGC catalog in any group is visible from 45 degrees north to 30 degrees south declination in my experience. So let's go ahead and push this up to 0.5 second exposure. This is 0.2. So here we have 6 stacks with 13 or 14 ignored at 0.5 seconds of Messier 31, 32, and 110. And the reason I need to rush through this is because I do believe we're starting to get some aperture blocking on the part of the roof tries. So let's try moving forward to 1 second exposure. Okay, we now have 7 stacked exposures at 1 second exposure each. 9 have been ignored, 9 have been stacked. Total exposure time 10 seconds. I do believe a high thin cloud is encroaching, and that may account for the diminution of the view. Here we have 6 stacks of 2 seconds exposure each. The lanes are visible, but they've been visible even under the 6-inch settings. We're at 2 seconds exposure, which basically is 10 times the exposure time, which should, if you follow the formulation, should pretty much make the equivalent of about, I would say, a 12-inch scope. I'd have to do a calculation on that using my standardized formula. But anyway, let's try now for 5-second exposure, which is the standard for NGC Tour with El Quattro. Here we have our 6 stacks. Not a bad view. I haven't adjusted the histogram at all. We're getting the dark lanes, obviously, with some texture in them. We can also see the core and extensions on Messier 110, and of course the very globular-esque Messier 32. I'm going to go ahead and allow you, we're going to do 10 seconds exposure, but I'm going to start it almost immediately so you can watch as the stacks develop. Okay, I think maybe the previous stack was incorporated in from 5 seconds. We now have 1 stack with 0 ignored at 10 seconds. 2 stacks. I can see it on the screen, you cannot. You can see it basically when it pops up and it says cannot current image. That usually means it's managed to triangulate, and there's plenty of stars on the screen. That's 3 stacks. Total exposure time 30 seconds. As soon as you see current image, it'll show you the next stack, stack 4, for total exposure time 40 seconds. A very nice view, but unfortunately this part of the sky is probably the best. 5 stacks with total exposure of 50 seconds. Very fine. We're obviously seeing much in the way of texture. We have now got our 6 stack. We have a satellite passage, nice view of 110. Let me go ahead and push it up now again. 6 stacks, 7, coming up on 7 stacks of 10 seconds each. Total exposure time 70 seconds. Okay, this is pretty much the way it looks when you first start out doing a long exposure time. As longer and longer, it looks pretty much like the 0.2 second exposure. We have 1 stack, but I'd say it's pretty much the 0.2 second exposure time. Scope aperture equivalent in this case. We have about 5 seconds left before we get our first stack at 30 seconds exposure time. Now, obviously, the view is not nearly as good as 6 stacks at 10 seconds. Let's see, we've got 2 stacks now. Once again, the view is not quite as good. Now, that could be due to passing high, thin clouds. So let's give it a chance to go all the way up to the typical 6 stacks, which I use for just about every exposure. And that 6 stacks comes out of using the Revolution 2 system, which basically allowed you to go up to 6 stacks maximum, and an exposure time maximum of 5 seconds. And that NGC tour with the Rev 2 system basically involved 2.5 seconds exposure time, not 5. And when it's stacked, it's simply stacked. It didn't triangulate. So if the scope did not track well enough, what you'd end up with is some smearage. But you'd get the stacks anyway. And I used to enjoy watching faint galaxies begin to make their presence seen on the screen. That was one way you could detect a galaxy or a nebula or planetary vis-a-vis stars, because stars would pop out right away and galaxies would take a while to develop, and that way you could be sure it was a galaxy. Whereas I've noticed with this system here, galaxies are initially reasonably present, but at the same time you're operating at a very low magnification, so if it's anything less than, say, magnitude 13, you probably wouldn't see it on the screen initially anyway. We now have 5 stacks. You can see the nebulosity of the clouds. So the galaxy itself is illuminating the clouds passing in front of it. And typically you could adjust that if you played with a histogram, but I am not going to do so. We have 5 stacks. I'm going to do a quick zoom in to see if we're getting any coma in the stars. There is a slight amount of stellar coma, so I'm going to back it out. And that may often be caused by a poor model, or perhaps the focus of the scope is a little blurry, so it's not able to fixate star locations quite as well. We've had our 6 stack. let's go ahead and try a 60-second exposure time. Once again, even though I set the exposure time to 60 seconds, it threw up initially a 0.2 second view because it managed to find enough triangulated stars. So we didn't have to wait the full 60 seconds to get any kind of view on the screen. Notice also, I do believe I centered up the galaxy reasonably well. We're seeing a little bit of driftage to the north, which tells me that maybe my declination of my scope model is a bit off. Now, typically what I might do with that is make a slight adjustment to the declination, but that would require me remodeling. So the next time I do a model, what I may do is I may tilt the scope. Since the stars are drifting a little bit north, that means we may be pointing I think it may be meaning we're pointing a little bit too far south. Ooh, striking. We just exploded with our first stack at 60 seconds. The core is simply overwhelming the galaxy. So at 60 seconds, our first stack, everything seems to be this. Let's see if we're getting some driftage in the stars. A little bit, but not too bad. Now, I'll bet you our next stack, we're definitely going to get some duplication of all the stellar disks. Now, once again, I'm going to point out that even though we're exposing for longer periods of time, we may be getting some aperture blocking, which will also cause stars to distort a little bit. We've got about 15 seconds left in the second stack. It says that we have 2 stacks, but we know we only have 1. It must have counted that initial 0.2 second stack as part of the stacking mechanism. There's no ignored stacks. We're doing an alignment now. We now have 3 stacks. Now notice how things brighten. Now I was told that when you do stacking, basically the luminosity of your studies remains the same, and what happens is the background sky gets diminished in intensity. That doesn't seem to be what we saw here. So let's watch when we get our next stack to see if we actually see a brightening of the core region, maybe looking down here at NGC. I believe this is 206. It's a star cloud with some emissive nebulosity associated with it. Massive stellar formation region. Okay, here we go. We got 15 seconds left, but I do want to check quickly to make sure that the stellar disks look good. Well, let's watch. I'm going to tell you when it says, as soon as it says on the screen, right now, current image, watch. It got brighter. As far as I can tell, we are actually getting a brighter image, and it's not simply due to contrast to the field of view. We're now about 13 minutes into this video, and what I'm going to do is we've got our 3 stacks. I'm going to try. Now, it looks like the stars are looking pretty good. Let's check one more time. A little bit of driftage and comatose with the stars drifting a little bit north. So once again, the model is either off or the declination is a little bit off. And we're seeing some driftage to the south of the azimuth due to the declination, and as a result, stars are tending to drift a little bit north. So, frankly, what I'm going to say to this is, I don't think we're going to be able to get more than a 60-second exposure, but why not give it a shot? I'm still waiting for it to get to be sky dark, which should be in another less than 10 minutes, and then we will try to give a start on our tour. Notice also, you see this black here? That means that the model in the scope is off and that the imager is stacking, and it's stacking things more and more to the left, causing a drift to the right side of the screen. So we are tending to drift a bit south with the models. I'm going to go ahead and give a shot for a 120-second exposure. Remember this one. Aha! Okay, I just initiated the 120-second exposure, but it did not revert to that more primeval view at 0.2 seconds. It looks like we're now getting maybe a 5-second view of the galaxy initially. So I'm going to pause because I don't want this to run on too much. But anyway, as soon as we get ready to put up our 120-second view, I'll reinitialize the Microsoft tool that I'm using to capture these images. Okay, we're just about to throw up the next image, but it didn't because it could not find any matching triangles at 120-second exposure time. So I'm going to bail on this, but I think the key thing I've learned from this experiment is that images do brighten up with stacks, and that you can follow the drift on the left part of the screen, and if you can somehow manage to think in terms of what's causing the drift, the right-hand side of the screen over here, I may be able to make some mechanical adjustments before I do my next model. And in this case, we may be looking a little too far because we're drifting south. So we may be looking a little too far north. That would be my hypothesis right now. I'd have to think it through. Anyway, I'm going to say on this portion of tonight's AstroVid, Carpe Noctem.